Okay, so that was our review of Arccosine. For every possible y-coordinate on the unit circle from -1 to 1, there's exactly one angle that corresponds to that from -π/2 to π/2. So when we use our calculator and we're doing inverse sine, we get a number. We know every time that number is going to be between -π/2 and π/2, and we know what that means. So then when we have problems, like you had some distance problems, and you can make sense of that and use that to solve, okay? So what about arccosine? What was the input meaning of arccosine, Matt?
Horizontal distance to the right of vertical diameter and radius lengths.
Okay.
For the x-coordinate on the unit circle.
All right, so yeah, so and we've kind of adjusted this to say what in fraction of radius length. I don't really know what I need to do here. I need to do a couple more spaces. No, over here. There we go, got it. All right, so horizontal distance right of vertical diameter and fraction of radius length, or x-coordinate on the unit circle, right? It's going to be the output of cosine, will be the input of arccosine. Okay, so what are all possible inputs? Derek? Okay, all possible fraction of a radii, horizontal distance, -1 to 1. So now we're talking about from here, -1 to 1, all possible horizontal distances. What's the meaning of the output? Written. Same angle. We know that angle is the same input for both sine and cosine, so it's going to be the same output for both arccosine and arcsine. Okay? And so now we've got every possible, we're thinking about every possible x-coordinate from -1 to 1. What range of angles, how do we cut down the angle range so that we get just one angle for every one of those from -1 to 1? This is easier than arcsine, right? Matt?
0 to pi.
Or Chad, sorry. Yeah. Right, so look where I got the cursor. So from -1 to 1, we need just one angle. The logical choice here would be just the angles from 0 to pi. So every x-coordinate would map up just to one angle from 0 to pi. And like I said, your web work problem should have led you through that. Where's it going? There it is. And so it's all kind of analogous to what we did with arcsine, but I think arccosine is even just a little easier because it's just naturally you get all the x-coordinates when you start at 0 and go to pi. You get every x-coordinate once and you're done. So I think it's a little easier. Okay. All right. So questions on that? So we emphasize this and we work on the input and output and what the possible, especially the possible outputs, because we should really understand the possible outputs, because when you start doing application problems using your calculator, you have to know what's going on with the number you're getting. Okay. So let's do some practice here. So I've got a remote control car. It drives around a circle with radius 8.5 feet, starting from the 3 o'clock position. After passing the 6 o'clock position, it stops 6 feet to the right of the vertical diameter. How far did the car travel around the circle? So let's try to kind of... So here we are. Well, first of all, before we talk about this car going around the circle, we got to decide what kind of car we want. So let's look at some choices here. We got the Formula One. What is that? Lamborghini? We got the Lamborghini? Okay, which one do you want? What about the monster truck? Which one do we want? I don't got a smart car. Sorry. I got to get a picture of smart car. That'd be awesome. All right. How many people want the Formula One? How many people want the Lamborghini? How many people want the monster truck?
Yeah.
Here we go. Where is it? Here it is. All right. Oh, it looks like it's in the wrong place. Let's see what happens here. Okay. So. Oh, negative. What's going on here? 0. All right, here we go. So what do we say? So it's gonna travel around the circle until it's 6 feet to the right. It passes the 6 o'clock position, and it'll be 6 feet to the right. Dang it. 6 feet to the right of the vertical diameter. And so we want to know how far. So here, this is 6 feet right here. So what's the question asked? The question asks, how far did the car travel around the circle? So this black highlighted distance here, how far did the car travel? So, perfectly legitimate question. We've got all the tools to do it now. So in order to get how far the car traveled, what do we really need? What's this really about? Getting what? Okay, arc length. And where is that arc length going to come from? So back earlier in the module, we can get arc length very quickly if we knew what about the truck? Yeah, some radians. Some people are saying angle. So we want the angle swept out by the truck around the circle. So if we knew that angle, then getting that arc length would be a snap. Okay, we'd be one step away. So what do we got? We have horizontal position, or kind of like x coordinate on the circle, and we want to find this angle so we can find the arc length. So this is a job for what? People are saying Arccosine. Input of Arccosine is? What's the input? Horizontal distance. That's what we have. Output is? Measure of an angle. So this certainly looks like used for Arccosine. Give ourselves some room here. Okay, Arccosine. So what is the input into Arccosine? What kind of thing is it? Fraction of a radius length. So we're going to put 6 feet in. How are we going to get the fraction that 6 is of the radius? 6 divided by 8.5 will be the x-coordinate on the unit circle, or the fraction of the radius that we are to the right. When we do that, so before we do that, in the calculator, what do we expect? Are we going to get this angle, this fourth quadrant angle? What are we going to get? What kind of angle are we going to get? So really, we're talking about this x-coordinate right here, right? 6 over 8.5. And so in the range of arccosine, so it's going to think, oh, you want this, which angle do you want? It's going to think about it from 0 to pi, right? The blue arc. And it's going to say, oh, your truck is up here. This is what the calculator is going to think. Here's where your truck is. I can give you that angle. Because that's the same distance to the right of the vertical diameter. Within our range from 0 to pi. Within our range from 0 to pi. Okay, so find it. So because we're going to eventually do arc length, so you can do this, you can set your calculator to degrees or radians or whatever you want, but because we're going to eventually do arc length, what's the most convenient? Radians, okay? Radians. So when you do radians, everyone should do this, you should get 0.787?
Yeah.
So what's the meaning of that number? What does that number mean? What did you just find? Measure of the angle in radians. Which angle? Where is 0.787 radians? Everyone should have a good idea of where 0.787 radians is. Fourth quadrant. It's in the fourth quadrant. What is a radian? Where does a radian come from? It's how many radius lengths are swept out. Where is 0.787 radius length swept out? In the fourth quadrant?
First.
Oh, right. First. Here. This is what it just gave you. It just gave you 0.787. Right there, that angle. Do you get it? Okay, so first we need to find our angle, and then we need to find our arc length. So can you figure out, so if we call oh, jeez, what happened? Well, that's the coolest thing I've seen all day. All right, let's see if this will. Whew. That was a close one. Okay. But we caught it all on video. All right. Let's see, what was I doing? Where was I going with this? Oh, I was going to write, this is theta. So we need our angle theta, and then we need S, the arc length. Okay, go. See if you can finish it. So based on the information you have, from arccosine you got 0.787. Can you figure out what theta is, which is the true angle swept by the truck into the fourth quadrant? And then S is the arc length. That's our final goal. Go, see if you can do it. This is on your exam. This kind of stuff is on your exam Friday. So just think of it like studying. Okay, see what you did. Nicholas, did you get theta? What was it? I want to know the process, not just the answer. So, what'd you do? You took 2 pi, I heard. This is what he did to get theta. Does it work? So, see, because it's the same horizontal distance, this openness right here is also 0.787. So our amount of openness that we want is going to be 2 pi less that right there. Another way to find theta. Does anyone do it a different way? That's kind of that's the most straightforward way. Did you do another way? Nice and loud. If you can whisper. If you can whisper. Is that?
Does it work if you add 3 pi over 2?
So 3 pi over 2 plus 0.787. So that would be if this angle right here was 0.787. Is that what that is? This one up here is, right? So that's a good thought, but that would only work if this one was 0.787. But it's this one. Yeah.
Can you find it by first finding S and then theta?
No, S is going to come from theta.
Oh, I found it without getting theta. I got the same answer for theta too.
So, okay, tell me what you did.
First you figure out.
Oh, did you? Okay, so you figured out this S here.
So I multiplied 8.5 times that to figure out how much feet it takes up out of the total feet of the circumference. Then you subtracted it, and that gives you the arc. And then you divide. I think. Yeah, you divide. Then you divide how much S is by the radius, and then you get 5.497. That's how you get theta.
Okay, but how did I didn't catch how you got S?
I found I converted so first I did 2 pi times the radius. That gives you the total feet around the whole.
Okay, right.
Then I found out how much 0.787 is in feet, and then I subtracted that
From the circumference.
Yeah.
Yep.
And then,
Yeah. So you found this amount of arc length right here,
yeah.
and then so that would be this amount also, and you subtracted that from the circumference. Yeah, but that was our final goal. So you don't have to go back and find the angle then, because that's what we wanted. We wanted that arc S. Yeah, and then you backtracked and found the angle from that. Yeah, that's fine. See what he did? So he just went right to this arc length. How could we get this arc length right here? How would you find that? 0.787 times 8.5. So this is totally valid. And then that's the same as this right here, which is the amount of the circle that he didn't travel to get back to the starting point. So you could take the circumference, 2 pi r, minus that would give you the S value. Okay, so if you did the angle first, how would you get S from the angle? Yeah, so it's just going to be, so this is what? Number of radius, this is the same number as the number of radius lengths that the truck took to get around there. So you're going to take that number of radius lengths times the radius, how long the radius is, and that gives you the total length in feet. What's the final answer? Anybody? 75 feet? Is that the right approximation? Is that what you got?
I got 6.72.
Okay, so some rounding error. Either we had rounding error or you had rounding error or something in between. Okay. Questions on this example? Okay, so let's do one more. So say same situation, but the truck stops 7 feet to the left of the vertical diameter for the second time. So it starts at the 3 pi position, and it stops when it reaches 7 feet to the left of the vertical diameter for the second time. For the second time. So, what do I mean by that? In what quadrant does it hit 7 feet to the left for the first time? Second quadrant, right? Somewhere around there. Okay? So then, what about the second time? Third. So right about there. Go. How far did the truck travel? How far did the truck go?
7 feet.
7 feet. 7 feet to the left of the vertical diameter for the second time. Oh, sure. Yeah, I couldn't hear. Sorry. It's okay. No problem. Okay, if you want to check, or you got a question, grab one of us, talk to the person next to you.
Yeah, so that's actually. Yeah. So that would be so this is. You would just add yeah.
Yeah, that's what.
Something different here. You got to catch it in the beginning. I don't see any. Show me what you're putting into Arccosine. Show me what you're putting in.
That's
So say something. Question. Yeah, that's what I was kind of explaining that. Exactly. Right. This angle right here was poinsettia. This should go. Because it's really close to, radical 2 over 2 splits it in half. It's 0.707. It's very, very close. I think it's just coincidence. It's coincidence because 0.787 is almost exactly halfway in the lake. So that's not going to work. You just got lucky. Yeah. Arccosine of what? I haven't seen anyone get it right yet. No one has it right. Arccosine of what? No one has it right yet. Yes, finally. Arccosine of what? Yes.
yes.
Arccosine of? I don't know the answer. I think Arccosine of what? I don't know what the answer is. I don't care about the answer. What? This, yes. Arccosine of? Yes. It doesn't have to be, but I mean to reflect what's going on here. Yeah. If you do 7, I mean you can figure it's still you're gonna get the first quadrant angle and you'll figure it out. The -7 reflects that you understand that what the real input is.
We're interested in
-7 over 8.5. If you put +7 and you understand what you got, you can still get the right answer. You can still figure it out. But to reflect what's really going on here, you should put in -7. That truly reflects because we're to the left. We're to the left. Who has that number? What is it? 2.54. What does that number mean? 2.54. So, what does it mean? Horizontal distance. Is it a horizontal distance? Measure the angle. Is it the measure of our angle theta? 2.54 is theta. No, 2.54 takes us to, remember the output of our cosine is going to be between 0 and pi, right? So 2.54 is the number of radians in that range from 0 to pi. So we're in, what quadrant are we in? So can you imagine what angle is 2.54? So both from our understanding of radians and the understanding of the situation. 2.54 is this angle, the blue one. We know that 3 radians is almost halfway around. So 2.54 is somewhere in the middle of the second quadrant. But that angle gives us the same horizontal coordinate as the one we have, or x-coordinate. Okay, so from 2.54, how are we going to get our angle theta? You want to take what? 2 pi minus that. So are you imagining that this is also 2.54 here?
Yes.
And so 2 pi minus that would give us our angle. That's one way to do it. Anyone do it a different way? Yeah? So you want to do pi minus that, and that would give you what? And that would be this one here. So if you did pi minus 2.54, you get 0.603. And then what would you do with that to get our angle? Multiply? Add it to? So you can do pi plus this 0.603 that came from, I multiplied. Pi minus our angle. 2 different ways of thinking about it that give the same result. So you can think about pi plus that angle 0.603 that I've done in black there, which comes from pi minus 2.54. Both give us an angle of 3 point what? Nice and loud. Is this making sense? Anybody have a question? Is that a question?
Can't you just, so you get your inverse cosine, I got 0.603 right away.
Because you did positive.
Yeah. And then you just add that to your pi.
Why? Why does it work?
Because it's that angle that corresponds to opposite. So that 0.603 is the same as 0.603 in the first quadrant. So
Right. As long as you know what you're doing. But so that's fine. But this is truly representing the situation because of where the truck is. It's to the left. And so that angle is negative. So that works as long as you it works.
So on the quiz, you want to show work that way or just
It just depends on the instructions. If it just says find the arc length, then it's up to you. But if I'm asking for how many, if the question was, what fraction of a radius length is the truck to the right of the vertical diameter, you got to put negative.
Yeah.
Does that make sense?
Yeah.
Okay. And then from this, easy from here, S equals 8.5 times the number of radius lengths. How far is it? 31.2? Agree? Okay. Any questions on Arccosine, Arcsine? Okay, so that is on the exam Friday. All right, so now let's take a look at this again. And now say the truck goes. I'm going to kind of transition to something new here. Say the truck just travels in the first quadrant so that it is hard to see. I'll try there. 3.5 feet to the right of the I'm going to say bye to the truck. I hope that's okay. So suppose it's now 3.5 feet to the right of the vertical diameter. So what I want you to do is, I want you to express, so this angle is theta. I want you to express the fraction of the radius that the truck is to the right of the vertical diameter in two different ways. Can you, in two different ways, express the fraction of the radius that the truck is to the right of the vertical diameter? You should all be able to do this. So, I'll write it out. Represent in two different ways the fraction of the radius that the truck is to the right of the vertical diameter. Think of it as a quiz. Can you do it? No calculator, you just write these down. Christian, did you get it?
Yeah.
Tell me.
The first one is just 3.5 over 8.5.
All right, let's write that down. So he said 3.5 over 8.5. Is that a legitimate way to represent the fraction of the radius that the car is to the right of the vertical diameter? Is that legit? Okay, you think he's got another one?
Sine inverse of 3.5 over 8.5?
Sine inverse of that. Sine inverse of that. What do we think? What else would give the fraction of the radius length to the right of the vertical diameter? So that's not right. What else would give it?
Sine cosine
Of?
3.5 over 8.5.
Cosine of 3.5 over 8.5. What's that? Cosine of theta.
No, inverse cosine.
Inverse cosine of theta. Gotta know. So here's the deal. You have to know those two functions and their inputs and outputs. What else? What function would give us an output of horizontal distance as a fraction of a radius length? Cosine. What's the input quantity into cosine? Angle swept counterclockwise. So this equals cosine of theta. Those are the two ways to represent it. Cosine theta and 3.5 over 8.5. What? Because before we started before by saying the arc cosine of 3.5 or 8.5, which is kind of the same as this. Okay, was there a question? Okay, so look, this is really cool. Wait, just give me a second. So I could take that 3.5 right there and I could move it down there, right? You see what happened? See it again, watch it. So we were saying it's 3.5 to the right, but that's really the same as the x-coordinate, which we could represent down there. Agreed?
Yeah.
And I could take this radius, 8.5, and I could move it here, right? Because that's the radius. Agreed? And then I could finish this triangle, right? So we got this is 3.5 down here. And what are we saying? We're saying the cosine of theta is a fraction of the radius length to the right of the vertical diameter. But in this triangle, we've got a right triangle. That 3.5 we call the adjacent side to the angle. It's next to the angle. And this is hypotenuse. So really, what we found is a cosine theta is the adjacent side to theta over the hypotenuse of that triangle. And so many of you have memorized this before, this formula, the cosine is adjacent over hypotenuse. But we see exactly where it comes from because adjacent over hypotenuse gives us the fraction of the radius length that you are to the right of the vertical diameter. That's where it comes from. 3.5 over 8.5 gives us that fraction of a radius. So it makes sense. It's not just something you memorize. It should make sense. Okay, exam Friday. Be ready. Yeah.
Can I ask a question?
Sure.
I didn't learn Sigma. I didn't learn Sigma. I don't get easier was like yes, I'm fine.
So let's do it. So there's the Arccosine and the sine. Is that right?
However you remember. So then it
So what's the sine of? Do it one thing at a time. Sine is of pi over 4.
square root. Negative square root. Yeah.
So to 2 over 2.
Oh, it's super.
So now, forget about that. So now here we are. What's the input into Arccosine? What's actually
Or the input is distance over distance.
output is in what range from what to what? Arccosine.
It's from negative 5
Negative pi over 2. So we're looking for the angle from negative pi over 2 to pi over 2. That has that vertical distance.
So because I was wondering, I was looking at it as if you do those, it would just be the same angle, since it has to be between.
Well, there's a reason we're asking these questions.
Yeah, no,
if it was
no,
just that, then
makes
there would be, right?
It makes sense to me.
There's a reason we're asking this.
Yeah.
Because you have to think about it. Because arcsine only gives you an angle between pi over 2, negative pi over 2, and pi over 2.
Yeah. Mm-hmm. That makes sense. Thank you.
So Friday is Friday Men's test.
So I'm gonna bring them. Is that what I've done before?
Yeah.
Just bring them to lecture Friday.
Yeah.